Assalamu alaikum. So today we will be building a relation between your sending end voltage and your reactive component. Okay. So this topic is important for both your power factor correction and your voltage control. Okay. So first we'll check out the relation of between these two, because for a power system network, if you see, this is the sending end voltage and this is the receiving end, and there is a transmission line. So power flows from the sending end to the receiving end. In AC circuits, it is said that whenever the current flows from one end to another, the leading phase will be we will be at a higher potential, and your lagging phase will be at a lower potential. Then only the current will flow. So here, if you consider, delta is at your leading and 0 degree is at your lagging, so the current will flow from your sending end to the receiving end. Okay. So here the power will flow from sending end to the receiving end. We will be calculating the power, that is your complex power at sending end. So complex power at the sending end is S. Okay, so that is your apparent power is equal to V into I. So this is a general term, but this star, that is your conjugate. Okay, this is very important for a three-phase power. This is a star and this is nothing but your conjugate of current. You can take voltage conjugate also. You can write it like this also, V conjugate I. This is also good, holds good, but V into I is not acceptable in your three-phase power. Okay, I have explained this thing in your interaction classes. Now here this is the complex power, this is the voltage, this is the current's conjugate. Now which end we are talking about? We are talking about the sending end. So here we will take sending end voltage. So sending end voltage is Vs at an angle delta. And what is your current? So the current flows from higher potential to the lower potential. So this is your Vs magnitude at an angle delta. Here you can write on magnitude minus Vr magnitude at an angle 0 divided by Jx. So Jx, you can write Jx as x at an angle 90 degree. Okay, so here I can write it x at an angle 90 degree because everything is in angular form. So I am writing like this, right? I hope no problem is there. Now this star is remaining there. Okay, now I will be calculating this thing. Now what will be the next terminology? So this is your sending end complex power. Now I can write it like this. So I will separate it. So I will write it V sending end upon xs, x at an angle. So this 90 will go up, delta minus 90, and then mod of Vr upon x at an angle minus 90 degree, and that is a star. Okay, next is I am taking the star inside. As you know, this is a conjugate, so it will it will change the sign of the angle. It won't affect the magnitude part, it will change the sign of the angle. So I'll write it. So if here it changes the sign, minus sign comes here. So I'll write it 90 minus delta minus mod of VR upon X at an angle 90 degree. Now this star goes off. Okay, now it's not a conjugate part. It's a simple thing. Now what will happen if I multiply it inside? So the angle, this magnitude gets multiplied, but the angle gets added up. So here I can write it Vs square upon X at an angle 90 minus delta plus delta. So that will cancel out, we will get 90. Okay. So next is Vs Vr upon X at an angle 90 plus delta. Okay, so finally what you will get is this term. So that is your sending end voltage. Indirectly this will get cut down and you will get this term, right? So final terms is this. This is my whole, this is my complex power coming from your sending end and to the receiving end. I hope it's holds good. Okay, so now I will be as we know that we need to find out the relation between sending end and Q. So this is a complex power. You can convert this complex power, as we know that this complex power will have two part, P plus JQ. Okay, and P is the cos component, cosine component, Q is the sine component. Okay, so if we take the sine component of this, it will give you Q. If we take the cos component, it will give you real part or cosine part. Okay, so then if I write it, as we are more preferred for your Q part, so I can write it like, so Qs is Vs square upon X sine part. Okay, sine 90 degree minus Vs Vr upon X sine 90 plus delta. Okay, so similarly if you want to find out the P part, you just have to replace sine by cos. So you'll get V into R upon X sine delta. Okay, so that's the relation you are getting in your for three-phase power. Now Qs you will get as sine 90 is 1, so we can write it Vs square upon X minus Vs Vr upon X sine 90 plus delta will be your cos delta. Using trigonometry I can write it like that. So then what will happen to Qs? So if you find out the Qs, that is, take out the common part. So Vs, I can take out Vs upon X, I am taking out common. So inside you will get Vs minus Vr cos delta. Okay, now now this is the relation with your Q, that is your reactive component, and the voltage. Okay, now consider, suppose we assume that your cos delta, okay, I am assuming like cos delta is approximately equal to 1. Okay, so if it is approximately equal to 1 means delta is almost equivalent to 0 degree. Okay, so there is no change in your delta with respect to P. Okay, so this is one of the assumption I am taking here. Okay, so what I can write, so QS is Vs upon X, Vs minus Vr, right? Okay, so if I am assuming this, I can write it like this. So what is Vs minus Vr? It is nothing but your voltage regulation. If you divide it with your Vs, you will get voltage regulation. Okay, so what I can write is that Qs is directly proportional to change in voltage, right? This is the change in voltage, so I can write it, or it is directly proportional to voltage regulation. So this is one of the important relation you need to know. Okay, now next, from this similar equation, this is one of the important equation. If I assume it 1, okay, so this is one of the relation. Qs is a directly proportional to your voltage regulation, and then here if you just shift something from here to here, if I want this x upon x qs upon v mod vs using this formula here, so what I can write, mod vs minus mod vr, right? So mod vr is equal to mod vs minus xqs upon mod vs, right? So there is a relation between your voltage sending end voltage and your reactive component. Okay, so if your voltage sending end voltage is constant, needs to be constant, if this qs needs to be constant. Okay, so if qs is varied, if qs sending end power reactive component varies, your sending end voltage changes. Okay, it comes up or dips down. If qs is positive, that means there will be a decrement in your sending end voltage. That means at the load and the sending load end you will get low voltage. If qs is negative, there will be a boost or high voltage appearance in your sending end. Okay, so this is one of the important relation you need to know, and this happens to be under which condition? This happens to be under cos delta must be equal to almost equivalent to 1. Okay, so this is one of the important relation of your voltage regulation. This is one of the voltage control will come using this, and both this is your why we are actually preferring power factor correction device, so that it also controls your voltage also. Okay, so we will be seeing one more thing in the next part of this lecture about what equipments we are using to control QS, and then it indirectly controls your voltage. Okay, thank you.